stars. Without them, there would be no planets, no light, and quite literally no us. Stars are the cosmic engines that produce photons, those massless, high-speed particles that allow us to observe everything in the world around us. The story of a star is one of constant, cyclical transformation. They are born and they die, only to rise again like a phoenix from the ashes. To truly understand their nature, we have to start our journey right here on Earth, looking back deep into our own past. For thousands of years, our ancestors gazed at the night sky and wondered about those shimmering dots. Were they mysterious signs from the gods? Or perhaps the spirits of our ancestors, watching over us from a world beyond? If we saw the sky through the eyes of someone living just a few centuries ago, we might imagine it as a massive, solid celestial dome. To them, the stars weren't giant balls of gas. They were simply tiny pinpricks or holes in that dome. Through these holes, an eternal, everlasting light would shine through from the other side. Depending on whether the hole was larger or smaller, the stars would appear brighter or dimmer to our eyes. It's actually striking how little we knew for so long. Even during the time of Copernicus, the true nature of those lights remained a complete mystery. In fact, we have only really understood what stars are for about 150 years at most. New stars are born from massive clouds of matter that fill the vast, empty reaches of cosmic space. This matter consists primarily of hydrogen and helium, mixed with a tiny hint of heavier elements that form microscopic grains of dust in the freezing void of the universe. Every so often, a major event, like the explosion of a distant supernova, sends a powerful shockwave through the region. This wave knocks the cloud of matter out of balance and triggers what scientists call a gravitational collapse. Cloud begins to cave in on itself, and the pressure and temperature at its center start to rise rapidly. We are now standing in the very center of one of the most magnificent events in the entire cosmos. Let's move a little closer. A star is being born. For a star to actually form, the pressure of this matter must increase so much that a process called nuclear fusion ignites. Specifically, we are talking about hydrogen atoms fusing together to create helium atoms. This reaction releases a staggering amount of energy, and that is exactly why a star begins to shine. But make no mistake, this isn't some fleeting celebrity. This is a cosmic hero with incredible properties. It has the power to pull in matter and forge entire planetary systems. Technically, we only officially call an object a star when these thermonuclear reactions begin deep within its core. This core, much like the star itself, is made of hydrogen, though stars born in the modern universe often contain other elements from the very start. If there is enough mass and enough pressure, the conversion of hydrogen into helium begins. For a medium-sized star like our Sun, this steady process of burning fuel will last for billions of years. But what about the stars that are much larger than our Sun? For those giants, the process might last only a few million years before they burn out. On the other end of the spectrum, we have the least massive stars, objects with only about 1% of the Sun's mass. These small stars burn their fuel so slowly that their journey can last for tens of billions of years. Closest and most important star to us is, of course, the Sun. With a diameter of 1.4 million kilometers, it is 109 times larger than Earth and over 330,000 times more massive. Yet, in the grand cosmic perspective, our Sun is officially classified as a yellow dwarf. The name dwarf can be misleading because it has nothing to do with being small. A dwarf is simply the most common type of star in the universe. Their color often tells us exactly what stage of life they are in. But to see true scale, we have to look at giants like Betelgeuse. This is one of the largest known stars, with a radius 1,000 times larger than that of our Sun. For medium-sized stars like the Sun, the end of life is a slow, dramatic transformation. Once the hydrogen in the core is exhausted, the star begins to swell, increasing its radius by dozens or even 100 times. Eventually, it sheds its outer layers, creating what we call a planetary nebula, a beautiful, glowing cloud of gas in various shapes. At its center, a small, incredibly hot remnant remains, known as a white dwarf. But not every object that looks like a star actually becomes one. There are pretenders called brown dwarfs. These objects have too little mass for nuclear fusion to ever begin. They are essentially dead stars from the start. And then there are black dwarfs, the cold, dark final stage of a brown dwarf that has completely lost its heat. Now, let's look at the true heavyweights. Stars with massive weights, 40 times the mass of our Sun or even more, create a different kind of monster, the neutron star. This is a tiny, rapidly rotating object only 20 kilometers wide, but its density is terrifying. To put it in perspective, if you could scoop up just 1 kitchen teaspoon of matter from a neutron star, it would weigh 1 billion tons. But even that isn't the strangest thing in the cosmos. Stars with even greater masses, perhaps 50 times that of the Sun, collapse into a black hole. This is a point so dense that nothing, not even light, can escape. In a black hole, all the known laws of physics simply break down. Finally, we witness the most beautiful and dangerous event in the universe, the supernova. When a star with at least 8 times the mass of the Sun runs out of fuel, it ends in a violent cataclysmic explosion. This explosion scatters heavy elements across the void, not just helium, but iron and calcium as well. Think about that for a moment. The iron in your blood and the calcium in your bones were forged in the heart of a dying star. Without the explosion of a supernova somewhere in the distant past, life on Earth wouldn't exist. Like a phoenix rising from the ashes, the death of a star provides the building blocks for new worlds. If other forms of life exist out there, they are made of exactly the same elements as we are. And that is truly a message that is out of this world.